Hello, this is Meteorology 113, Lecture 12, Indoor Air Pollution. This is the second lecture of Course Module 5, Local and Indoor Air Pollution. This final lecture of Meteorology 113 will cover indoor air pollution. We will first give an overview of the topic. We will then survey important common sources of indoor air pollution. We will conclude with additional details about prevention measures and control to maintain healthy air in the indoor environment. The contents of this lecture slide set were built from several previously presented material. First, acknowledgement is given to Dennis Asha of Breathe, California of the Bay Area, who presented a slide set to Meteorology 113 Spring Semester 2012 on indoor air pollution. Much of the material in this presentation comes from Dennis's presentation. In addition, content for this lecture slide set comes from material on the following links. Some other resources students can refer to in order to learn more about indoor air pollution and ways to ensure clean air in your home are provided here. Indoor air pollution. Overview. The motivation for learning about indoor air pollution is rather clear. We spend lots of time indoors, including both the home and workplace. Our exposure to harmful air pollutants is therefore dependent on the air quality of our indoor environment. What may not be as clear is how much more time individuals spend indoors versus outdoors. The charts below show data compiled by the California Air Resources Board to determine this. On the left is a pie chart for adults and teens, and on the right is the same, but for children. As seen in both cases, we spend most of our time on average indoors at home. Adults on average about 60% of the time, and children on average about 75% of the time. A significant time is also spent indoors away from home. For example, at work or school. Combined, home and elsewhere, the data indicate that we spend on average about 80 to 90% of our time indoors. Indoor air quality is therefore extremely important in determining total exposure to air pollutants. Yet, as we will see, certain air pollutants are more common indoors than others. Throughout the remainder of this lecture, we will focus primarily on indoor air pollutants in homes. So we proceed with a virtual tour around a fictitious home to identify common sources of indoor air pollution. Starting at the upper right is outdoor air pollution. Depending on ventilation rates, outdoor air penetrates indoors such that, absent any indoor sources, concentrations of atmospheric gases indoors will match those outdoors. For example, carbon dioxide concentrations indoors will eventually reach around 400 parts per million, the typical outdoor air concentration, assuming that no people, plants, or pets are inside exhaling CO2 and no other sources of CO2 inside are present. However, sources of various contaminants exist in the indoor environment, and we can proceed to identify some of the main ones. Proceeding clockwise around the home, we first encounter molds and bacteria. Mold in particular can be a problem in dark, moist areas, especially in locations that are cool and humid, such as bathrooms. Molds release spores and mycotoxins that can cause illness and allergy if inhaled. Next, there are various chemicals that vaporize from cleaning products, especially when stored or used. Secondhand smoke exists if there are smokers. Pet hairs and dander, or dead skin of pets similar to dandruff, can cause allergic reactions if inhaled. carbon monoxide fumes from any source of combustion within homes, including stoves, fireplaces, cars if there is an attached garage, and water heaters, can build up if ventilation is insufficient. A gas called radon, formed by decay of radioactive elements in the earth, can infiltrate through cracks and seams in homes and through basements into the living space of an indoor environment. Radon exposure poses long-term health risks if inhaled. Chemicals from paints and solvents can vaporize into homes when used or stored. Various smoke and other combustion gases can build up in concentrations, for example, fireplace and stoves, as we've already mentioned with respect to carbon monoxide. Finally, the building material itself of homes can be a source of harmful gases, particularly of formaldehyde, which we will cover in more detail shortly. This is a quick survey. We will discuss some of these in more depth now. The following slide organizes some of these indoor air pollutants according to the severity of adverse possible health effects they can cause. On the left are possible lethal effects. Tobacco smoke, of course, is known to increase the risk of premature death. Radon gas, which can penetrate from underground into homes, also has been linked to premature mortality. Carbon monoxide is particularly dangerous since it is odorless and colorless and can cause immediate death if the concentrations are high enough, something we talked about earlier in this semester with respect to carbon monoxide. Non-lethal but sometimes serious or at least irritating effects are associated with other indoor pollutants such as lead from paints if the home used paints that contained lead from earlier, if they were built a long time ago, for example, when lead was common in paints, as well as the presence of mildew and mold and vapors of VOCs from paints, cleaning product, and other sources. These can cause sometimes serious impairments or at least irritation and discomfort. To conclude this overview, we give some points about regulations. First, there are no regulations like outdoor ambient air quality standards for indoor air. Instead, indoor air quality is attempted to be maintained by various small regulations and advisory best practices. For example, newly built and most modern structures are built to codes that require cleaner building materials and modern effective ventilation systems. This is in addition to many other code requirements for energy efficiency and other goals. Home sales and apartments must ensure that smoke alarms are installed and operating at all times. The smoke alarms should also have carbon monoxide detection capability in addition to detection capability of smoke. Household products such as paints, solvents, and cleaning products in California are all required to have Proposition 65 warning labels if they contain substances known to be toxic, carcinogenic, or associated with other health risks. Finally, various OSHA or Occupational Safety and Health Agency regulations exist to ensure a clean workplace environment. Indoor air pollution. Sources. We now proceed with some further details on specific indoor air pollutants that we just covered. First, we cover carbon monoxide. Fireplaces, stoves, cars, in attached garages, water heaters, and other combustion sources in homes can emit carbon monoxide into homes. Ensure proper function of these equipment. Ensure proper ventilation, especially if these sources are in enclosed places. Make sure smoke alarms also have carbon monoxide sensors. Mold can cause allergic reactions through inhalation of spores and mycotoxins. Bathrooms are a common source of mold, but it can occur anywhere where humidity is high and ventilation is poor. Using a ventilation fan or opening a window will help to control moisture and inhibit mold growth. Check also for plumbing leaks. Dust mites. Dust mites feed off dead skin cells. They can trigger allergy and asthma attacks. Regularly vacuum soft surfaces such as carpeting, upholstery, stuffed toys, and drapes. Wash pillows, blankets, and bed sheets in hot water weekly. Pet dander and hair. Pets can trigger allergy and asthma attacks due to dander and hair. Keep them out of the sleeping areas and away from upholstered furniture, carpets, and stuffed toys. Vacuum and clean carpets, rugs, and furniture often. VOCs. We discussed volatile organic compounds much in the semester with respect to outdoor air. Many of these VOCs, as we discussed in the last lecture, are toxic air contaminants. Common household cleaners release VOCs both when used and stored. Keep all products away from children. Consider purchasing cleaners without VOCs. Check also Proposition 65 warning labels. Formaldehyde. Formaldehyde is a toxic air contaminant. It is widely used in composite wood products that have resins and is in building materials and insulation, glues, permanent pressed fabrics, paints, lacquers, and other coatings. Formaldehyde is also released into the air from formaldehyde-containing personal care products like shampoos, soaps, hair care products, body washes, and nail polish. Check for formaldehyde-free products. Radon. Radon is a naturally occurring radioactive gas that can enter a home through cracks and openings in floors and walls that are in contact with ground. Radon is among the leading causes of lung cancer among non-smokers in the U.S. Testing your home is simple and inexpensive. Also shown on this slide are maps, in this case of California, where each county is rated with respect to the highest, moderate, and lowest potential for radon exposure. These are called Zone 1, Zone 2, and Zone 3. Specifically, certain substances in the earth are more prone to releasing radon than others, and depending on which county you live in, you can be in one of those places or another. This can be looked up, and any purchases of homes require that the potential for radon exposure is explicitly stated to potential home buyers. So this is some information here about radon, and you can see here a link where you can learn more. Indoor air pollution, prevention and control. We now give a few more details about indoor air pollution prevention and control. Seen here are the four main preventative measures. Starting on the upper left is contaminant source control, which simply is the act of identifying sources of indoor air pollution in your homes and then taking preventative measures to eliminate or reduce air contaminants from these. The remaining three are measures to ensure the indoor air environment is not conducive to the buildup of sources and or high indoor air contaminant concentrations regardless of sources. On the upper right is humidity management, which is mainly important to reduce the likelihood of mold and mildew buildup. On the lower right is filtration, which is used to keep indoor air clean from particulate pollution penetrating from outdoors or adjacent rooms where dust and other particles may be generated. Finally, on the lower left is probably the most important preventative measure, a properly functioning ventilation system. For older homes, this mainly means windows. However, newer homes and practically all commercial buildings and workplaces have modern heating, ventilation, and air conditioning, or HVAC systems. Some specifics on conditions for reducing mold growth are provided here. For homes equipped with modern HVAC systems with temperature and humidity controls, proper functioning should be checked to verify values around those shown on the slide are maintained. A dehumidifier can also be purchased to maintain relative humidity levels in certain rooms of the home. This slide gives a layout of the functioning of a typical building ventilation system. The system works by recirculating indoor air, but pulling in a small percentage of outdoor air alongside it. Typically, 90% of resupplied air to the indoor environment is from indoor air, and 10% is from outdoor air. 20 cubic feet per minute per person is a typical setting applied for the air resupply rate to a room. Since this is per person, the settings on a ventilation system should be optimized with respect to either how many people are typically inside at a given time or for a reasonably high value to ensure a margin of safety. Further details of a typical HVAC system are provided on this lower right panel for those interested. For particle infiltration, we see here a chart similar to one shown in an earlier lecture with the size of particles on the horizontal axis and types of particulate on the vertical. Note that the horizontal axis ranges from submicron particles to 100 microns. 10 micrometers and smaller, the size cut for respirable particulate that can penetrate more into the lungs, is around here on the plot. On the bottom of the graphic is filter type. The key thing to notice is that most common filters generally are not sufficient to filter out tiny submicron particles. We learned, however, that these submicron particles are the most dangerous since they penetrate deepest into the lungs. To ensure filtration of submicron particles, one would need a high-efficiency air filter. Electrical precipitators are more expensive and complex systems, generally more used in commercial and industrial airspace settings.